customers today, right? So what I hear in general in my conversations, both at executive level and right down at the sysadmin level and the data center level, is that it's clear that businesses are starting to adopt this idea that you want to go to the cloud. You want to take advantage of the agility the cloud brings, along with subscription services, the ability to be able to take advantage of services that are being executed and run for you. Completely understand that, but at the same time, I also hear all of your challenges. The challenges that you're running on, say, an ERP platform that has your customizations built into it for your business processes, and how do you get them changed so that in a world quickly so you can adopt, for example, ERP in the cloud from a cloud provider such as Oracle. That's a hard challenge. And actually, you know, many of us are looking for a halfway place, but on that transition to the cloud that enables us to run our businesses and manage that people change process in our business at the same time as adopting technologies. Now, from a deployment point of view, right, we've always deployed and designed and architected based on best of breed, right? If you look at IT as a history, we've started off in monolithic mainframe type worlds with a single vendor. And then, you know, choice came and all of a sudden we had what I describe as my children's dressing technique, which is any color, anything goes as long as it's comfortable and we're happy with it, right? So a heterogeneous data center. And then over time, as we've matured with operational maturity, we've got to a point where we've built design patterns where we've chosen best in breed, and we're designing those and architecting them where we think we can offer control, stability, security, and more important for many of us, performance to meet the business requirements. And a lot of that architectural design I tend to see is based around this concept that the data and where the data is created is the gravity source. That's where we focus the problem to start with. And then the application tier thing sort of comes closer to that and gets standardized over time. And actually the other thing I see is that the application tier, you know, modernizes quite quickly. If you look at how we used to use Oracle Forms on the command line in a text environment, for example, and now how we see our modern day applications in HTML5 on our mobile phones and our iPads, the world has moved at that presentation layer very quickly, and so the application tier changes. But actually the data structure and the data that's sat in that database actually has probably been around for about 20 years for many of you as businesses, right? And so that has helped us. So when we've architected, we've built these high performance places for our applications that we can have manage and we can control really tightly. And, you know, that's brought along a number of best practices and challenges for us as organizations. How do we size? How do we predict buy hardware today that's going to be running the business in 5 years' time and still performing, right? Bear in mind that I can't take advantage of any other hardware that's kicking around just to stretch my capacity in these legacy applications. So I have limited burst. But what I do also have, though, is complete control. I'm able to build an Oracle RAC cluster, for example, for HA inside my data center. I'm able to implement Active Data Guard to my disaster recovery data center. I'm able to put a third site in, even if I want to, as a storage bunker or a cyber bunker. And I have complete control and I can test that, and I know and I control every single little bell and whistle, so I know I can deliver a service level to the business. And that control has given us, comes at a cost. And it comes at a cost in terms of it's a fixed cost. I can't pay as I consume. I have to pay up front. I have to design all this in, and I have to make it work. But we've been making it work for years, right? So this is how I see architecture today working. Now, what I'm starting to hear is actually that from yourselves is that you're starting to get to the point that you want to run in a world where actually the active development or the services available in the cloud are becoming so appealing that we're starting to consider, you know, separating and moving away from that data gravity into a world where we're maybe having cloud services and analytical services provided in the cloud, say from Azure or from Oracle OCI or Google, but still keep our database on premises because we've got data sovereignty and we've got laws and we're worried, and that's the course of our data. And so we're starting to see this separation. The other way of approaching this is that we actually go, we'll move the Oracle database, we'll move that software, we'll move it off best of breed as a platform, and we'll move it into the standardized cloud and run it. And the challenge with moving it into the standard cloud is that all of a sudden, these clouds that have been designed for, application workloads at best, without enterprise thinking, suddenly start showing you poor performance in terms of latency and reads, or are limited in the number of IOPS they can offer you. They don't have the availability you had before, right? This concept of, even if you don't follow Oracle MAA, this concept of doing disaster recovery via storage replication doesn't exist in clouds. How do you do that, okay? And then what you tend to find is that as you start to adopt these, and I'll talk about a customer that's gone through this journey and the story we have with them, that you suddenly discover costs that you'd never even thought were there before, because you'd physically bought network equipment in your data center, and you've never really thought about the cost of moving data between data centers before. You had your link, it was a fixed price link, you just consumed it. Never before was you worried about which megabyte of data should you send and not send. And what you tend to find is, because of standardization, you make your world increasingly more complex as well to manage and to monitor. Now, one alternative to this is this idea of a hybrid cloud, right? And a hybrid cloud lets me, put my keep my best practice hardware running on premises. Okay, so I could be running an Exadata or even a supercluster for some of you, right? And I still want to run that for 3 years. I keep that in my data center. I've got all of my security around it. I've got all of my data protection. I've got all of my operations teams. And then I could go to the cloud and I could be running, I don't know, Kubernetes, and I could do a cloud native development, start building services that are consuming data from that central database. The challenge with that is nobody I'm aware of has managed to speed up the speed of light, okay? So all of a sudden I've got this problem called latency, and I've got long distance connections, and I have high latency for the data acquisition, so my business starts to complain, call centers are suddenly waiting an extra minute for a screen to refresh is not a good situation to be in. I have performance issues where I can't guarantee the bandwidth that I have, for example. And I start in worst case, start to see these SQL timeouts, okay? And that's not a good place to be either. But I got the flexibility in the cloud, right? And that's great. So what if you could have a solution where you could have it all? You could have the flexibility of delivering in the cloud or consuming a service in the cloud that extends your application out and makes you more agile, but actually allows you to keep complete control of your infrastructure as you have it today in a data center, in your own cage with your own security, and you're able to then manage that. And more importantly, you could consume, say, a service from Google Cloud, another one from AWS, another one from Oracle, and another one from Azure, and keep your data centrally. Okay? And this is what we see as cloud adjacent technology. And obviously my slides here are talking about the use of Oracle Exadata, because we see that as the most optimal place for you to be running your databases, both for performance, but also for availability and control. But what we're talking about is this ability to offer like a direct, local, low latency connection between your infrastructure you own and all of the clouds that are available to you. That way you can burst, you have excellent database performance, you have that high availability you had, but you're starting to reduce your costs as well, right? So, and it gives you increased business agility. So the use case I want to talk about is I've got a couple. I've got two financial customers, and unfortunately I can't name them. They've not agreed to be public references today. One of them we actively worked on a POC, and that's what I'm going to talk about now with them. and then you can describe, I'll go through their thinking process, and then I'll talk about another customer reference that's moved, and then I'll talk about a retailer as well. And hopefully that will give you help. And please keep the questions coming on the Q&A. I will take the time to answer them at the end, wherever possible. So this financial institution wanted to move all of their, they basically had a direction from their board that they had to move all of their, or close their data centers and move to the cloud. That was the direction they were given, ultimately, okay? They were a heavy Oracle Business Suite user, and those of you that use eBusiness Suite or have been involved in eBusiness Suite will know that it's extremely data-centric and extremely chatty between its application tiers. So you need that low latency connection between the two. They already had consolidated their databases into what they termed a sort of private database cloud, and built that on top of Exadata as their technical platform underneath. And so they'd already got used to, having SQL offload, and used to the Exadata minimizing brownouts to less than 2 seconds, rather than 3 minutes in their legacy infrastructure. So their business consumers had got used to that sort of service level, even though it wasn't contracted. And so they were thinking, how do they manage that as well? They also looked at this concept of, and I'll talk about this later, of doing hybrid cloud between two cloud providers. So could you move some of your architecture to one cloud provider, say the eBusiness Suite into OCI, and then their Microsoft applications into Azure? And actually what they were finding was they didn't have enough critical mass in both for acquisition for both clouds to be sustainable in that matter. So ultimately what they decided was, let's see if we can prototype running Oracle in AWS. Okay, that was their solution to this, was let's go to AWS, let's go with a commoditized, standardized cloud platform of infrastructure as a service, and surely we can build this. Now, the first thing to say is that, a lot of people are moving to the cloud for agility. This proof of concept took 14, and I'll repeat that again, 14 months to complete on AWS. And there was a large focus on rewriting software to try and fix problems as they were discovering them due to the infrastructure. And we all need to optimize when we move, because what's the point of moving? We need to improve as we go along, but 14 months is not a fast process. Now, what they discovered at the time was there were some inherent AWS limitations that was different to their normal approach. So the first one was, inside AWS at the time, there was no real application cluster available to them. So they couldn't just suddenly scale database instances across additional compute nodes when they needed to, for example, at end of month, payroll, for example, or closing the books. There was no extra CPUs to take consumption on for that sort of burst workload. They also had no built-in HA, right? So in the absence of Oracle RAC, how do you start thinking about high availability, right? Our businesses can't pursue, your online processing or your trading platform can't afford to have 5 minutes out while VMs being relocated somewhere else in the cloud, okay? They also had insufficient compute scalability. They were finding that the compute nodes couldn't scale to the number of cores they sort of required for each database instance. And then the other challenge they had was the storage performance in the cloud as well. And I'll touch on some of these numbers in a minute. They were sort of the root causes of the symptoms they were seeing. And those symptoms was just poor database performance, if we're honest, okay? The implementation became more and more complex over time. And all of a sudden, this complexity increased an AWS sort of monthly cost bill that just kept increasing as the complexity increased. And of course, the other challenge they had was when they started looking at the number of nodes they had running and the number of options they were using, all of a sudden, and it wasn't just the Oracle database, but it was other applications as well, was that software licenses and support costs were increasing as well. Now, the picture on the right here depicts their architecture for each and every use case just to try and get a level of high availability. So they would deploy an Oracle database in an availability zone 1. They would then run data guard traffic to an availability zone 2, which may well have been in the same data center. Okay. And then they also were doing a local data guard within the availabilities as well. So all of a sudden I'm running 4 instances. And then they took advantage of the availability zone 3 to provide an observer and data guard instance to cause failover between them all to just try and get a level of availability. Now, if Oracle had decided that HA should be implemented by data guard, we wouldn't be delivering real application cluster and continuing to develop and reduce the latencies in that HA clustering software that also gives you scalability, right? So this isn't the ideal world to approaching this challenge in the first place. The other problem that they found was one of just pure performance. So this is at the time, and this is back in May, AWS highest I/O volume support was 64,000 I/O operations per second and about a gigabyte of throughput, okay? And that was off their best SSD volumes they could provide. Now, I'm just going to point out here that AWS IOPS are single I/O operations, okay? Whenever Oracle talks about database IOPS or SQL IOPS, that is a sum of a number of disk IOs, because, you know, an SSD disk IO is going to be 4K, a SQL query is generally 8K, maybe it's 64K database blocks, and we deliver that as a single IO operation in Exadata. So if you compare that 64,000 IO operations to just a base rack with Extreme Flash configured, then just for writes, we already do 1 million in a quarter rack implementation, okay, of SQL IOPS. So take that IOP number from Amazon and multiply it by 2 to 4 times just to get where you need to be, and then you start seeing this massive difference. And the difference was around 13 times. And actually, from a throughput point of view of just pure bandwidth, we were 64 times greater. And remember, this is a customer that was already using this platform, okay? So there's a choice here, right? You either go to a complex world and be less performant, and you try and make it work, or you start thinking, is there another way? Now, I talked about the architecture they had of the replications between disaster recovery or HA within an availability zone or data center, and then a replication to a third, and then a data guard broker. But that was just for production, okay? So for every single environment they had, an EBS generally has a minimum of 5 environments. They repeated that each time for each environment, okay? So you ended up with development, you ended up with testing, then you end up with production, and then a replication to DR. And actually, I've not drawn on the picture here, but you also have pre-production user acceptance test as well. Okay, so imagine the complexity all of a sudden you're doing and putting the burden on your database administrators to manage all of that in a new environment in the cloud and try to make that work. It's just extremely complex, extremely hard, and extremely poor performing at the same time. So I'll just give you an idea, and this, I think this is worth you understanding if you are looking at moving Oracle databases to AWS, for example. And I don't need to just pick on AWS here. Google and Azure have the similar challenges in terms of data access for a database, right? Unless you're using Exadata in your cloud, nobody can deliver that sort of I/O performance at a database level other than Exadata. I might be biased. I'm the lead for Exadata here in EMEA, but I've yet to see anyone else be able to do this on premises either. And a lot of that is due to the smart capabilities we put in the storage cells that are actually doing even more work for you than just pure compute node IOPS. So from the largest AWS instance, and then you put a quarter rack of storage, we're 5.9 times more performance on a quarter rack, okay? On a full rack, we get 12 times bigger, and we offer this scaling as linear, right? And if you took Oracle Cloud Service, you can move from a base to a quarter to a half or a for example. On premises, we can offer additional storage cells or compute nodes as we grow. So all of this is flexible for you. And that's just on the number of active cores, right? If you start looking at your flash storage or your IOPS or your storage throughput, the numbers start to get so embarrassing that actually there's a level of accuracy that's missing on these slides, right? The other thing we're seeing, and actually this was from the financial customer, was that from a total cost of ownership over 3 years, it was cheaper to do this on Oracle in a cloud adjacency model with Equinix as a partner by 64 times over 3 years. And I think this is something we need to start looking at, which is what's our cost of ownership to deliver the service versus the cost of acquisition. Because it's really cheap to buy and really quick and easy to buy, but what's our actual cost of ownership over the time? So the answer we finally came up with was by partnering with Equinix. I've touched on this, and I can see that from the attendees, we've got people from over Europe and the Middle East. So be assured that Equinix has data centers in most of the geographies of the attendees here. And what Equinix is able to do is actually provide hosting services of your own hardware into their data center, but then provide low latency links into any cloud you require, be that Oracle Cloud, AWS, Azure, or Google, okay? So, and they'll provide that link and manage that via their cloud exchange. So ultimately what this financial customer did was it implemented eBusiness Suite. They kept it on Exadata. They moved their Exadatas into 2 sites in Ashburn and Chicago. They took their own networking equipment, they took their own data protection, they took their own managing, monitoring, and security tools, implemented that there, but then actually took advantage of the Equinix Oracle Exchange, or Cloud Exchange, should I say, to then connect to AWS to move their application tier into the cloud and give them some flexibility there. The latencies were extremely low latent, but they got the benefits of both worlds, okay? They exceeded all their performance, latency, security, and availability requirements that they'd set. They were able to close their traditional data centers and release that land cost and release both the OpEx spend on running that data centers as well as the capital that they were currently spending. They managed to retain control of their databases and their data, right? They were in sovereign control. They had complete control. They were still where they needed it to be. They knew that they could turn off the link whenever they wanted and still retain their data. They found this simpler and less expensive. From an IT department, there was no change for them as such in terms of day-to-day operations and runbooks. At the database tier, at the application tier, they were able to scale up and scale down as they wanted to and get the benefit from cloud, and that's great. And then they were started looking at other processes and other services they could then adopt to then start transforming their business at the same time. So look, if you were going to do this, ultimately what you're able to do here is, relocate your hardware or refresh your hardware onto on-premises hardware of either a capital acquisition model or even a cloud at customer model, and you can retain control and keep the locality within your country and your region. But what we're able to do in partnership with Equinix is then connect you to any of the public clouds that are out there via low latency connections. And of course, you can do this with both production and DR. So you can release your own data center costs, move whichever platforms you want to move, and off you go. And I think it's worth pointing out here, I've used recovery appliance on the slides on purpose. So the zero data loss recovery appliance is exactly that. It's designed to protect every single transaction going on in your business that's going into an Oracle database and not lose any. And actually, when you start looking at data protection services in the cloud, it's a very different world. And so actually, I have a customer right now who is adopting database services in a public cloud, who has decided to still back up and protect in their own country to their own recovery appliance as a way of retaining data, being an insurance for them, and mitigating risks. So their view is if a cloud provider suddenly disappeared for any particular reason, then actually they would have all their data and they could restore that to another cloud provider if needed. It gives them migration, it gives them choice. And so don't just think, I know I've talked specifically about running the database, but you could also protect the database with recovery appliances as well. The performance, we reckon, is less than 2 milliseconds latency. We've proven that time and time again. And obviously, you've got the scale and performance of both the Exadata and recovery appliance here as well. You get all the availability you architect, but most importantly, you're in control, okay? So I touched on this on the previous slide, and I think it's worth touching on it now. With Oracle, we can offer you different consumption methods, right? And this is because we as a vendor are unique in the fact that what we sell to you on premises, we can also offer to you as via our leasing and financial capabilities and our services organization as a right to use method where we can offer you capacity on demand, but also manage it for you within your own data center, and we can do that on a fixed capacity as well, okay? Then we can take you and take a node of our public cloud and move that to your data center and allow you to still have the cloud flexibility, the cloud tooling, the cloud consumption model, the cloud subscription, and put that inside your data center or your data center cage at Equinix, for example, and allow you to have your own dedicated nodes in your own control with your own network around it and your own security controls. Yes, you're still interfacing to Oracle's public cloud. Yes, you've still got Oracle administration coming in to run the platform for you, but actually they have no access to your data whatsoever. So you can then take advantage of the cloud within your own data center or next to another service. And of course, then we have Oracle's Generation 2 OCI cloud, where we have Exadata and infrastructure all together, all managed by Oracle in Oracle's data center at the same price point as Cloud at Customer. And we run everything for you, okay? And that's your choice. Now, one of the things, and I'll talk about this in a minute, is that we can start helping you we've already started partnering with Microsoft. Ourselves and Microsoft have recognized that you want this multi-cloud, best cloud for the right workload type approach. And so we've got a partnership in place, and we're starting to see that appear in physical implementations where we can do fast connects between key data centers from Azure to Oracle Cloud as well. Now, one of our retailers, for example, did this. They wanted public cloud flexibility to handle peak demands, but they also discovered that AWS couldn't run their databases for them. So their approach was application tier and the data into the Equinix data center, and then to scale the application tier into the public cloud as and when they needed to. And they originally started with a presentation layer, which, as I discussed at the start, generally changes on a 2 to 3 year basis, right? And that's ideal in cloud. It's almost transient in terms of the life it lives compared to the database. Generally your data is around for 20 to 25 years. In some of your businesses, it's around for 100 years, right? So that approach seems to make sense. They found it simple, they found it the most cost effective, and actually it helped them retain their compliance to PCI for credit card transactions, for example. And that's critical for their businesses. It's the only way not the only way, but the largest way that they actually receive payments for their goods and services. Touched on this already. We have a partnership between our own cloud, Oracle's public cloud, and Microsoft, which allows you to put low latency connections between the two in key regions that we have available at the moment. Many of those are very Europe focused right now. And so it allows you to build simple cross-cloud setups. In fact, I was with a customer 3 days ago in a virtual conference where we just demonstrated this live with them, right? And it was a 10-minute setup. And so that would, for example, give the ability to take advantage of .NET running in Azure, but also Exadata running in Oracle Public Cloud together, right? So, or even if you want to take that one step further and have the advantage of autonomous transaction processing or autonomous data warehouse with a .NET front end, you have that flexibility as well. More importantly, from a security point of view, everything's got federated identity and single sign-on capabilities. So we reduce the security footprint for you at the same time. And of course, we've got direct low latency connections. And on here, I'm out of date on these slides, I do apologize. It says that it's Oracle Ashbourne, Azure US East, but we also have this in London and Amsterdam as well. And also in Asia, I believe there's an implementation as well. And there's more coming, okay? So again, as I said at the start, right, I've talked specifically about Exadata today, but you know, Oracle has a complete portfolio of application servers and Spark servers that are world leading in terms of risk-based processing. We have high performance storage that's able to offer you deduplication, compression, and object storage capabilities, for example, that you might want to retain that data on there. And so, although I've given you Exadata use cases today, the same functionality could be delivered via any of Oracle's portfolio in partnership with this hybrid cloud model. So please don't let my presentation constrain your thinking about the art of the possible, okay? I think it's worth remembering that, you know, you've still got key applications out there, I know you do, that are still running on best-in-breed risk processor Spark technology, say Spark M8, that still provide key business functionality for you. And it may be easier for you to relocate those than it is for you to re-implement and migrate to a new platform. So I touched on this before. Here's a quick little map of where Equinix is available for you to consume and to partner with Oracle across a number of different geography cities, where we can offer this sort of flexibility and this hybrid cloud approach of you owning your own on-premise assets, whilst also still being able to take advantage of everyone else's cloud provision as well. And of course, they can go into far more than we can as well in terms of providing additional telecoms and a complete solution. And we're more than happy to work with them as well. And with that, I will take 30 seconds just to scan the questions. I hope that was informative for you. I really didn't want to keep you for a whole hour, but I'm hoping that 35 minutes of content was what you needed, really. Okay, so I'm just scanning the questions. Okay, so one of the ones was a question around how is this technology applied for helping security or ensuring security? So by you being able to place your data and your networking and your security, it's in your control at that point, right? No longer are you focused on having to adopt a cloud provider's security model. You're still following it yourself. Now, the downside to that is that your security may not be as great as that provided by a security provider. So, for example, if you wanted to have Oracle's cloud security control services for you, so Alcacid, for example, or Calcube, should I say, then you could still run that service in our cloud, have a fast connection through, and still be able to monitor and provide security services for you. Of course, you should also be following the maximum availability architecture for high security. We can provide a link to that in the slides at the end. I'll add an extra slide of documentation of how to secure your data as well. If you take advantage of Oracle Cloud at Customer, we actually implement by default things such as table space encryption, and then we give you a design or help you with a design pattern around protecting the access to the data with Database Vault, as well as providing true audit as well with Audit Vault as well. So, and of course you can do that on premises as well. But really what we're doing is helping you keep your security level as it is, and then working with you to improve it. I hope that answers the question. So is there any chance other cloud vendors would use Oracle hardware? I think that's an interesting concept. Oracle would welcome any of the cloud vendors out there to come and procure Oracle hardware. That, the reality is what we're starting to see is this best-in-breed approach where each cloud provider runs the infrastructure best that they can with their own design, right? And that's how we've built Oracle Cloud, from Oracle SaaS applications running on top of Exadata and Oracle X8 servers, for example, right through to our PaaS services where we're using Exadata as a cloud service, all running on top of X8 servers again, right? So it's about how much control you have and then how much value a cloud provider can then provide on top. And we continue to work that. That's why our cloud has key security features in it that we can implement because we own our own hardware. It's down to other cloud vendors and their strategy. I can't answer for them myself. Okay, so, and I should have touched on this one. So there is a question which is, how do you communicate your application tier that's in the cloud back to the Equinix data center? So let me just load it. I think this slide shows it the best. Okay, so what Equinix has is this concept of cloud exchange. It has either, Equinix is either hosting cloud services for every cloud provider, or it has already physical links to the Equinix data center from each of the cloud data centers, okay? So that cloud exchange is the true value for you. You can use, for example, OCI Fast Connect from Oracle as a dedicated link, and you would create that link into Equinix at that point. The same for Azure, I can't remember Azure's name, and the same for AWS. These are services that you can consume, and the endpoints are low latency endpoints already pre-built for you within Equinix. Hopefully that answers your question. So it's straight TCP/IP networking from your point of view. You would have load balancers, I assume, or you would take advantage maybe of load balancers in the cloud, but then a HA link back to your databases within Equinix, for example. Okay, so there was a request for an architecture deployment for your business suite as a doc to help you move and improve that. And so we probably should, I'm happy to be contacted offline. My email address is christian.toms@oracle.com, and I'm happy to help you find that as well. Okay, so the other question I got was around the security about AWS back to an Exadata. The thing here is that you would implement your own security and design. We're more than happy to help you. For example, we could put database firewalls and your own firewalls in front of your Exadata to the connection from AWS, so that, for example, you're able to then ensure that only pre-approved SQL can go through to the Exadata from the application tier, that your whitelisted IP addresses from the AWS zone, for example, is there as well. We can help you with this. We've helped other customers as well. It's just a question we can work with. And I think, okay, so there's another question which is, does the hardware have to be Oracle hardware hosted in Equinix? Could it be a mixture? Absolutely, it can be a mixture. Okay, so Equinix is agnostic to the hardware. We see this as providing a solution to you for Oracle databases, or say maybe Spark servers. But if you're running on something else, that's also possible as well. Okay. So thank you for the questions. If anyone else has any more, I'm happy to stay online. If not, I thank you all for your precious time. and enjoy the rest of your day. Thank you.